All right, so we're back. Sorry about that. Not sure what happened. So we're still going over a couple more problems, and then we'll move on. But because I still think it's important to practice, but it's okay. We're back. So next one that we had that I had up was 8.19, and this was z-score and confidence levels. So it's asking us to figure out which one is used. Which z-score is used in a 90%, 98%, and 99.9% confidence interval, right? And so we can look this up, look up in the back of the book. Not that we can really need to do this, right? But it's important that we can, should we need to for whatever reason. And so if we look at a bunch of z-scores in the back, if you can go back and consult the tables, you can find exactly what we're looking for. So if we, let's say it's Appendix A, and the way that we would maybe go about this is then finding the right column, right? So what probability we could do, right? And then we could figure it out that way. So this is Appendix A, you'll see that there's a standard normal chart there. So what we usually try to do, right, is if we are finding a particular z-score, if we're trying to figure this out, we know that already that 90% is 1.645. We know that for B, 98% is going to be 2.33, and C is 3.29. Point being is that we don't necessarily, don't really need to know these values because we're not ever really going to use them. But we can look this up if needed. So it's really, up to you to decide when, how we're going to do this. But just keep in mind, right, that we can do this and use the values that we used before to, sort this out, right? And so for our last one, right, last little problem just for educational purposes, right, this is going to be number 8.25. And this question is asking us about exit poll predictions. We have an exit poll of 1,400 people in state gubernatorial elections or electing for governor. We have 660 are Democrats, and they voted democratically. And we have 740 GOP Republican people who voted for that. So, what is this question asking us to do, right? Treating the sample as a random sample from the population of voters, so we don't have to deal with that assumption. So if we go back to number A, we know that these are random, right? Who would you predict the winner? Base your decision on 95% confidence interval, right? So when we think about say they voted, 60 say they voted for the Democratic candidate, and 740 say they voted for the Republican candidate. So, could we go off of the winner, who's going to win, right? Here's what we could do, right? How would we go about solving this? So the first thing to do, we would sample a proportion, right? And so what the saying is to do, is there enough, less certainty where we could actually declare a winner based off of this. So this is more about is this a close call or too close to call? This is what this question is asking. So how would we go about this, right? So it's like pretty straightforward, right? So if we use the democratic sample, right? So we know the proportion is going to be 660 over 1400. And this is going to be equal to 0.471. We would find next the standard error, which, as we've already done before, is p times 1 p times 1 minus p over n. Put that under square root. And we know for this one, right, that this is going to be equal to 0.471 times 1 minus 0.471 divided by 1400, correct? Put it here, and this is going to equal to 0.013. Then if we get into let me put a different color here because it's a new step. 95% confidence interval is going to equal to 0.471 plus or minus 1.96, right? Because we're using the 95% confidence level times our standard error, which is 0.013. And this is going to be bounded between 0.446 colon 0.496, right? So now it's asking us, like, could we actually predict the winner, right? So in this case, yes, because the CI is below 50% of that mark. It doesn't cover it, right? So it doesn't seem like the Democrat didn't receive more than half votes. We could also, as a special note, we used it from the Democrat, but we could also do this, do this problem if we used the GOP numbers. So that part is like irrelevant, right? And so we would have figured that out, and we'd seen that we got the same answer, and that it's too close to call because we're not looking for any numbers. This is really looking more about a decision being made. Decision made about answer. And so that's one way that we can figure this out, right? And so, but that was for 95%, right? So we have part B, which wants to know what happens if we had a 99% CI. So the good news is, right, is that we already have, we don't need to solve a lot of this because we already did the work. So we already know that it's 0.471 for the proportion that we're estimating. And we know the standard error is equal to 0.013. So the only thing that's going to change is our confidence interval. And basically what we're trying to figure out is going to be 0.471 plus or minus, and instead of 1.96, we use 2.58 times our standard error. So this isn't, so there's nothing like wonky here, right? And we would see that we would come out to, for our interval here, it'd be 0.437 to 0.506. And so our decision would change here, right? So here, with the 99% interval, this is too close to call. So based off of how much uncertainty we're willing to accept or how sure we wanted to be, here we're not making a call. And here we do make the call. So that's the difference between those two. And so this just sort of illustrates how if you change and manipulate your uncertainty, how you can make different decisions based off of that. All right, so good. Thanks for holding out for the quick glitch, but hopefully it makes sense now. We'll see you guys in the next video.